13.1, use trigonometry with right triangles. So the first problems, they give you a triangle and they say to evaluate the 6 trig functions of the angle theta with the given information. So you start out with a triangle and they give you that this angle is theta. This side over here is 3 and this side is 8. So to be able to evaluate all 6 trig functions, I need to find that third side, okay, which is something you should have probably at least learned in Algebra 1. If not, you saw it in geometry, but the Pythagorean theorem is how we're going to find that other side. So remember, that's a squared plus b squared equals c squared. So 8 squared plus 3 squared equals c squared. So then 64 plus 9. So then we're going to have the square root of 73 is equal to c. Now, normally when we take the square root, we have a plus and minus value, right? But for a length of a side, we can't have a negative length, so we only care about the positive one. So this side is going to be the square root of 73. So now I'm going to set up to write all of my trig functions. Now I will tell you I prefer for them to be in this order. It makes it a lot easier for me to grade. And I will always write them in this order: sine, cosine, tangent, cosecant, secant, cotangent, and then that's also what they go with, so it makes your life a lot easier. So sine is opposite over hypotenuse. So opposite, 3 over the square root of 73. But I cannot have a square root in the denominator, so I'm going to rationalize it by multiplying by the square root of 73 over the square root of 73. And so then that's going to give me 3 square root of 73 over 73. And so that would be your sine value. Cosine is adjacent, so that's 8 over the hypotenuse square root of 73. So again, I need to multiply by the square root of 73 over the square root of 73 because I need to rationalize it. So that's going to give me 8 square root of 73 over 73. If at any point it can be reduced, like if, say, 3 went into 73 or 8 went into 73 or whatever, I would reduce that, but it's not reducible, so I don't have to. Tangent is opposite over adjacent, so that's going to be 3 over 8. Now, once you've done that, you've done the hard part, because now when we go to do the other side, we just flip them over. Okay, that's why I lined them up this way. So cosecant, we just flip it. It's a square root of 73 over 3. Secant is cosine flipped, so square root of 73 over 8. And cotangent is going to be 8 over 3. Now, you could flip this one, but that's going to cause you to rationalize and have to cancel stuff, so I always go back to the original when I flip it, because the less work, the better. All right, 8. So they give you this triangle this time. They give you this angle. They tell you that the hypotenuse is 2 squared to 17. And this bottom side length is 8. So I need to find the other side. So Pythagorean theorem again, but now I have this side over here, so a squared plus 8 squared is equal to 2 squared to 17 squared. So that's going to be a squared plus 64 is equal to 4 times 17, that's 68. So then subtract 64, a squared equals 4, so a equals 2. So my other side length is going to be 2. Then I'm going to set up just like I did up here. Alright, so sine of theta, so theta's over here now, so opposite over hypotenuse, so it's going to be 2 over 2 squared root of 17. Now, I already can see that these 2's are going to cancel, okay, because I have one top and bottom. I'm going to multiply by the square root of 17 over the square root of 17 to rationalize it. And so that's going to give me the square root of 17 over 17 for that one. Cosine is adjacent over hypotenuse, so that's going to be 8 over 2 square root of 17. So again, 2 and 8 cancel. You need to multiply by square root of 17 over the square root of 17. So I get 4 root 17 over 17. Then tangent, opposite over adjacent, so that's 2 over 8, which reduces to 1 over 4. So then cosecant, if you want, since you've already canceled stuff, it's not going to change when you flip it. Like, it's not going to all of a sudden, like, not cancel or something. So you can just go ahead and write this as the square root of 17 if you want, because that would be the square root of 17 over 1. Secant is going to be square root of 17 over 4. And cotangent, since we've already reduced, I would use the reduced one, so that's just going to be 4. 4 over 1. Now, as you get more comfortable, if you don't want to write this multiplying by the square root of 17 over the square root of 17, you don't have to write that. Okay? Just know that if you go straight to here, and let's say you didn't write any of that, and your answer's wrong, you're going to get more points off because I have no idea where you went wrong. Okay? So I would recommend at a minimum you write this like the 2 over the 2 root 17, and then if you want to go straight to root 17 over 17, that's fine, and like just skip what I've written in green. That would be my personal recommendation. I normally don't let people do that in this first section, but I feel like if you can cancel it and reduce it, then you should be good to go. Or if you feel like you can do that in your head, but if you want to write it, also totally fine. Alright, the next problems, you're basically doing the same thing, but instead of them giving you a triangle this time, They tell you that theta is an acute angle of a right triangle, so it just means an angle less than 90 degrees. Find the values of the other 5 trig functions of theta. So I still want you to set it up like this and show all 6 when you do it, but you're technically only finding the other 5 because they're giving you one of them. So cosine of theta is equal to 5/8 is what they're telling you. So I'm going to go ahead and set up over here my chart to put them in. So they've told me cosine of theta is 5/8, so I can go ahead and write that one in. Since I know cosine, what must secant be? 8/5. So now I'm going to personally draw my triangle so that way I can see what's happening. So I've got triangle here. I'm going to call this theta. You can call whatever angle theta that you want other than the right angle. So obviously that can't be theta. I've got adjacent over hypotenuse, so that's going to be 5 is down here, 8 is here, and I need to find this side. So Pythagorean theorem, a squared plus 5 squared equals 8 squared. So a squared is equal to 64 minus 25, which is 39. Is that right? Yeah. So a is going to be equal to the square root of 39. So square root of 39 is going here. So then I can find the other 4 trig functions that I don't already have. So sine opposite over hypotenuse, so square root of 39 over 8. Tangent is opposite over adjacent, so square root of 39 over 5. Cosecant, move this over so I have a little more room, is going to be 8 over the square root of 39. Again, you could skip this, but multiplying by the square root of 39 over the square root of 39 would give us 8 root 39 over 39. And then cotangent would be 5 over the square root of 39, multiplying by square root of 39 over the square root of 39, gives us 5 root 39 over 39. Okay. Let's see. My book is literally falling. I don't know what's happening. Stay. Okay. 12. Cosecant of theta is equal to 10 over 7. So I'm going to set up my table. All right, so they gave me cosecant, which is 10 over 7. So I know sine must be 7 over 10. So I think right now you probably are going to find it easier to set up your triangle knowing sine, cosine, or tangent. Eventually you'll realize, or maybe, I don't know. You'll figure out that, oh, it's not that bad to have to draw the triangle from the other ones because it's just hypotenuse over opposite or adjacent or whatever for the given scenario. But anyways, it's probably easier right now to think about it in terms of sine. So I'm going to set up my triangle. And I always pretty much draw my triangles like going this direction, but if your preference is to draw them the other way, that's totally fine also. So this is going to be my angle theta. Opposite is 7, hypotenuse is 10. So you can modify the Pythagorean theorem to just be like whatever, like a squared is equal to c squared minus b squared. So that's honestly what I do to save a bunch of time, is just going ahead and writing the modified one. So a squared is equal to 10 squared minus 49, or minus 7 squared, going to be 49. So 100 minus 49 is going to be 51. So a is going to be equal to the square root of 51. So that's going to be that other side. So cosine, adjacent over hypotenuse, square root of 51 over 10. Tangent, opposite over adjacent, so that's going to be 7 over the square root of 51, which is going to be 7 root 51 over 51. So like if you want to just go straight to that, that's fine too. Secant is going to be 10 over the square root of 51, or 10 root 51 over 51. And cotangent, we just flip this one, it's going to be square root of 51 over 7. All right, any questions on those before I move on to the next part? All right, find the exact values of x and y. So they give us a triangle that looks like this. Tell us that this angle down here is 45 degrees. This is x, this is y, this is the square root of 21. All right, so some things about this. We're trying to find x and y. What do we know about the sum of the angles inside of a triangle?
Must equal 180.
I have to equal 180. So I've got a 90 and a 45, so what must my other angle be? 45. So that one also has to be 45. Now, do you remember back in geometry when you learned about two special triangles?
Like congruency?
Nope. Like something in regard to their angles.
Oh, like in like the 30, 60, 90.
Yep, a 30, 60, 90 and a 45, 45, 90 triangle. Those are two special types. And so I'm going to draw what the comparative triangle would be over here with, as if it were just the basic one that you would have learned. So your basic one with the 45, 45, 90, you would have had a side length of 1, side length of 1, and a side length of the square root of 2. So I'm going to use this triangle and compare their side lengths to figure out what x and y are going to be. So I'm going to have y over the square root of 21, okay? So y comparatively to this one is equal to the same comparison over here, 1 over the square root of 2. And I'm going to cross multiply so that's going to be y square root of 2 is equal to the square root of 21. Then I'm going to divide by the square root of 2, so y is equal to the square root of 21 over the square root of 2. which multiplying by the square root of 2 over square root of 2 to rationalize it is going to give me the square root of 42 over 2. Now, because this is a 45, 45, 90, if y is the square root of 42 over 2, what must x also be?
Same thing.
Yep, so this is also going to be x. So that's a 45, 45, 90. Let's also look at one that's a 30, 60, 90. So look at 19. So they give us triangle like this. This is 30. So we said we must also know that this is 60. They gave us 12, y, and x. So I'm going to draw a comparative triangle over here. Does anybody remember what the side lengths of a 30, 60, 90 triangle are? No. All right, it's 1, 2, and root 3. So 1 goes over here, 2 is on the hypotenuse, and the square root of 3 is over here opposite the 60-degree angle. So I'm going to look at this the same way I did the other one, but now because I have obviously an x and a y, and they are not going to be equal because they're not the same angle, I'll have to actually cross multiply twice. But I'm going to do it the same way. So I'm going to have 12 over y is equal to the square root of 3 over 2. And then I'm going to cross multiply. So that's going to give me 24 is equal to y times the square root of 3. Divide by the square root of 3 is going to be 24 over the square root of 3, which is 24 times the square root of 3 over 3, which can be reduced because 24 and 3 can cancel. So that's going to be 8 square root of 3 is going to be equal to y. So that's my y value. Then x, we've got 12 over x is equal to square root of 3 over 1. Which obviously I don't really need the 1, but. So that's going to be 12 equals x square root of 3. Let's divide by that. 12 over the square root of 3 is equal to 12 square root of 3 over 3. 12 and 3 cancel, so that's going to be 4 root 3 is equal to x. And so that's how you would find the other side length for that one. So you'll have one like that in your homework to do to try to figure it out. All right, this next one is going to probably require the use of your calculator. For at least part of it. They give you, well actually, for these next several problems, they give you a triangle that's already, it's not filled out, it just has the stuff on it, so the sides and the angles and all that. So they give you that triangle, and then they're going to tell you two pieces of information. So they're telling us that angle B is 53 degrees and side A is 12. So I usually like to redraw the triangle over here and fill in stuff as I get it. But then also what I'm going to do is I'm going to set up, just like I do with sine, cosine, tangent, all that, I'm going to set up a little table that's going to have all the angles in it and all the side lengths in it so that I can get all the information, and it makes it, again, much easier for me to grade when you put all the information together, because if I can't find something, I'm obviously going to mark it wrong. So if you put it all together, there can be no confusion. So angle B is over here, that's 53 degrees. Side A is 12. So side A is this one. Now, I know it's a right triangle, so I know that angle C is 90 degrees. So, how would I possibly go about finding that other angle?
Add C and B together.
Or it's like 90 plus 53 plus 180.
Okay, so I'm going to add those together and I'm going to subtract that from 180. So I'm going to have, to find angle A, I'm going to do 180 minus 90 minus 53, which is going to be 37 degrees. Your book is going to round anything that needs to be, what? The book is going to round anything that needs to be rounded to 2 decimal places. When we get to 13.5 and 13.6, I'm going to have you round to the nearest whole number because it makes things easier. So I'm going to go ahead and just say round to the nearest whole number. So when you check your answers in the back, or if you're checking them in the back, whatever, just know that theirs are going to be rounded. I don't care if you do decimal places in this section, but who really likes decimals? Just round to the nearest whole number. So I need to find my other 2 side lengths now. So I need to find side length B and side length C. So I'm going to use your calculator to do that, but first of all we're going to set it up. So we're going to say the sine of this angle over here, so the sine of, or well actually, let's do tangent first because it'll be easier. I'm going to do the tangent of 53 degrees because that was something that was given to me, so I can't be but so wrong with that. So tangent of 53 degrees is equal to opposite, which is going to be side B, over adjacent, which is 12. So then I'm going to multiply by 12. So B is going to be equal to 12 times the tangent of 53. Now, just because I don't know what you've used your calculator for in the past, or if you have a sibling that's used your calculator or something, I want to make sure that you're in the right mode so that you're not getting answers wrong. So if you hit mode up here at the top, you're going to look down and you should see something that says radian and something that says degree. Make sure degree is highlighted. If radian is highlighted, you're going to get the wrong answer. And then you're just going to type it in as 12, tangent, 53. So that side length B, rounding to the nearest whole number, is going to be 16. So at this point, you have a couple options. You can either go through and use the Pythagorean theorem to find side length C, or you can use another trig function in your calculator to do it. Since I know you know the Pythagorean theorem, I'm going to show you another trig function. I'm going to use cosine this time. So I'm going to do the cosine of 37, just to do something different. So the cosine of 37 is equal to 16 over C. So that's what I'm trying to find. So obviously I have C on the bottom over here, and I'm trying to find that. So I'm going to swap C in the cosine of 37. So I'm going to have C is equal to 16 over the cosine of 37. So then you can type that in as 16 divided by the cosine of 37. So rounding to the nearest whole number, C is going to be equal to 20. And so then you have solved a triangle. Do you have a question? No? Okay.
I forgot how you, like, when you put tan 53, like, why did you pick 53? I forgot why you did that.
Because that was the angle that I was going from.
It was good.
Can you just go for, like, 37 if you wanted to?
I mean, you could have used 37, but you would have used different side lengths at that point. Like, if I had done the tangent
I
of
see.
37, it would have been
I see.
equal to 12 over. At that point, I didn't know that side.
I see.
So, yeah, you can use whatever trig function you want. I mean, I would stick to sine, cosine, and tangent, make your life easier, but you can use whichever one you would prefer. Let's see. Let's do 26. So again, they give you the same triangle that we had up here. Angle A is 49 degrees and side C is 27. So I'm going to draw my triangle here. All right, so set it up. I'm going to put in my given information. All right, so angle B would be what? Or how would I find it? No,
No.
you're off by a little bit.
Oh, 40.
Yep. 180 minus 90 minus 41, or minus 49 would be 41. So 41 degrees is going to be angle B. So now I need to solve for side A and side B. So the only side that I already know is the hypotenuse. So that means I can't use tangent at this point because I don't have enough information to use tangent. So I can either use sine or cosine. Which one do you want to use, and of which angle? Cosine of what? Which angle?
B.
Of angle B?
Yes.
Alright, so cosine of 41 is equal to A over 27. So A is going to be equal to 27 cosine of 41. And you would just type that in, 27 cosine 41, which is going to end up being 20. So side A is going to be 20. Now I need to do side B. So now I could use tangent if you want, or you could still use sine or cosine. Which one do you want to use to find side B?
Cosine of 41. Wait, no.
We just did that.
49.
Cosine of 49. All right, cosine of 49 is going to be B over 27. So B is going to be equal to 27 cosine of 49. So that's going to round to 18. So side length of 18 for that one. All right, do we need to see another one, or are we okay on those? All right, I'm going to go ahead and give you your problems. You more than likely won't finish, so I'm going to give you time tomorrow to work on them as well. Three, 7, 11, 13, 17, 23, and 27. So like I said, you'll have time tomorrow. You don't need to do this for homework, plus it's Wednesday.